Hello students, welcome to the video session for the topic inverter. Okay, so let's get some introduction about the inverter. So inverter is a device which converts DC input supply voltage into symmetric AC voltage of desired magnitude and frequency at output side. Okay, so inverter is a device which convert DC input to AC output at desired magnitude and frequency. Okay, so ideal inverter have sinusoidal output. See, DC means this is the DC, AC means this is the AC like this. Okay, this is the AC. So it is our input and it is our output. Okay, so in case of ideal inverter we get sinusoidal output. So this is the sinusoidal output, and in case of practical inverter we get non-sinusoidal waveform. Non-sinusoidal means it may be like this. Okay, this is a non-sinusoidal alternating waveform. Understood? So if the input DC voltage is a voltage source, that means in case of inverter there are two categories of inverters, that is the voltage source inverter, current source inverter. Okay, so when the source is voltage source, then it is voltage source inverter named as VSI, and when the source is current source, then it is named as CSI, current source inverter. Okay, here input to the circuit is a current source. So understood clearly? VSI, CSI. So VSI means voltage source inverter. Here voltage is the input, and CSI current source. Is the input. In case of VSI, voltage source is the input. In case of CSI, current source is the input. So next is the application. So these are the application of inverter. So let's just view about this. Low and medium power applications, square wave or quasi square wave voltage may be acceptable. For high power application, low distorted sinusoidal waveform are required. So using high speed power semiconductor devices, the harmonic content at the output can be reduced by PWM technique. Industrial applications, so mainly what are the industrial applications are there? See, variable AC motor, induction heating, standby power supply, UPS, these are all the applications, industrial applications. So UPS is a very well known term that everybody knows, everybody is used in their home inverter, in the computer, and in those cases UPS are used. Okay, and these are all the industrial applications, and inputs are battery, fuel cell, solar cell, etc., other DC sources. So next is the classification of inverter. So what is the classification? So inverter classified as two types of inverter, that is single phase inverter, three phase inverter. So if we get single phase in the output, okay, in the AC output part, then that is the single phase inverter, and if we get three phase AC in the output side, then that is the three phase inverter. Okay, then turn on and turn off controlling devices. That means in inverter circuit, what are the semiconductor devices used? Actually, what is the role of semiconductor device? It is only act as a switch. That means we have to turn on and turn it off in the as per the requirement. Okay, that is the only thing. So here the turn on and turn off controlling devices, controlling semiconductor devices are bipolar junction transistor, BJT can be used, MOSFET can be used, IGBT can be used, GTO can be used. Another one is the SCR, thyristor. It can also be used. Clear? So in the next we will discuss about the actually in this session we will discuss and we will give more important about the single phase inverter, because in your syllabus you have single phase inverter, not three phase. In your higher level study you will study about the three phase inverters. So let's discuss about the single phase inverter. So actually single phase inverter, under this single phase inverter we will study full bridge inverter, okay, and also we will have we will study okay, so we will study half bridge and full bridge inverter, okay. So actually first of all we will discuss about the half bridge inverter and then we will discuss about the full bridge inverter, okay. That means in inverter we will study full bridge inverter and half bridge inverter also. So we will discuss all these things one by one, okay. So let's discuss about single phase full bridge inverter can be justified with a switching scheme of full bridge converter. And square wave AC output voltage is synthesized from a DC input by closing and opening the switch in an appropriate sequence. See, in this bridge inverter we will give DC input and we get AC output in the square wave form, okay. And how we get this square wave form? In appropriate sequence, turn on and turn off by closing and opening the semiconductor device, we get square wave AC output, okay. So the output voltage label can be plus VDC minus VDC. This is plus VDC minus VDC and 0. So this is the label of output voltage. So these are the label. So we will discuss in detail, okay. So next go to so first we discuss about the single phase half bridge inverter, its circuit diagram, its operation, its waveform, everything, okay. So first we go to the half bridge inverter, single phase half bridge inverter. So first of all, see the circuit diagram. What you have to see, this is the 3-wire DC supply, okay. 3-wire because its out wire is like this. This is the 3-wire DC supply, okay. And we have 2 thyristor switch. These are the semiconductor switch and 2 bypass diode or free wheel diode, okay. So here this is the basic type of single phase half bridge inverter, and its construction, what you see, it consists of 2 switches T1 T2, 2 diodes T1 T2, 1 3-wire DC supply, okay, and the diodes are called feedback diode, okay. So everything you know about the circuit diagram. Then next go to the operation part. So this is the operation. So let's first see how it will operate. So when we give supply, what happens, see, when we give supply, here the magnitude of the DC supply is Vs by 2 and Vs by 2, here also Vs by 2, okay. So these things, this I0 and V0, these are our positive direction of output voltage and output current. So first when we give DC supply, this T1 and this T2 both are in forward bias mode. So when we give the gate pulse to these thyristors, then this switch will close and output current will flow through the circuit. That means when I give when I give, see, when I give this is the IG1, IG2, this is gate pulse 1, gate pulse 2, okay. So initially IG1 is given like this. So when IG1, you know the circuit is like this, remember, this is the, here we have load, this is the circuit, this is another part of the circuit, here also thyristor is there, okay, and here we have bypass diode, yes, This is T1, T2. This is load. It is Vs by 2. It is Vs by 2. This is load. Okay. So initially Ig1 is there. Ig1 given to the thyristor T1. Ig1 means gate pulse. So when gate pulse is given, current will flow like this, and this is our assumed direction of current. So it is same. That means here our output is in the forward direction or positive direction. So here output is like this, and its magnitude is Vs by 2. Clear? This is the output voltage waveform, and at this point Ig1 is 0 and Ig2 is given. That means now thyristor T1 is turned off by force commutation, and now T2 is turned on because T2 given by Ig2. Gate pulse given to the T2 by Ig2. So once Ig2 is given to thyristor T2, then current will flow like this. Here the current direction is opposite with the assumed current direction, assumed output current direction. So now we get the output voltage like this in the reverse direction. That is, this label is what? This label is minus Vs by 2. Okay. Then again, you see, in this part T1 is conducted, in this part T2 is conducted, it is written over here. Again, at this point T2 is, Ig2 is 0, that means thyristor T2 is turned off, and then Ig1 is given, that means thyristor T1 is turned on. So again current flow in this direction. So again we get this output magnitude of Vs by 2. Again from this point Ig2 is given. So here due to Ig2 we get the output voltage like this. In this way it will go on. Okay. So see here the average output voltage waveform is like this, alternating. Understood? So this is one half and this is another half. Its reverse is this one, and again it is repeated from this point, positive half then negative half. That means one time period for the output side waveform is this one T, and from this point to this point it is T by 2. Understood? And this is, what is this? Current I0 waveform. Though in case of resistive load our output current is in phase with the output voltage. That's why output current waveform is similar with the output voltage. Understood? And output current I0 is equal to simply V0 by R. That is equal to Vs by 2R. Clear? So now you clearly understood about the what you understood, what are the conclusion, that for resistive load V0 is equal to Vs by 2 magnitude, and I0 is equal to V0 by R. So here V0 RMS is Vs by 2 and V0 average is 0. And why average is 0? Because see, in positive half it is Vs by 2. In negative half it is also minus Vs by 2. That means whatever in positive direction, that much magnitude is here in the negative half also. So the average is 0. So clearly understood about the single phase half bridge inverter. Okay. So in the next part we will discuss about single phase full bridge inverter. Okay. Thank you.